Okay, so she gave a challenge, and the challenge was, how many moves on average is it going to take a randomly moving rook, making legal rook moves, to get back to where it started? So let's see if we can work through that problem
Well,
the way she taught us to.
well, so we should put a number. We should put a number on each square equal to the number of possible moves each rook has.
Okay.
So, well, from each square, it doesn't matter what square you're on. The rook can move 1, 2, 3, 4, 5, 6, 7 ways. Moves this way. You can go 1, 2, 3, 4, 5, 6, 7, and 7 moves this way.
Okay. Now, but what happens? I'm going to ask your brother. What happens here on that square?
Well, you can move 1, 2, or 3 this way, and you can move 1, 2, 3, or 4 that way. You can move 1 or 2 up, or 1, 2, 3, 4, or 5 down.
Okay.
So any space you can go 7 across, and then 7 up or down.
Okay. So what does that mean? Our distribution of rooks is going to
So
look like.
It's all there's 14 rooks on each square.
Okay.
Yeah.
So, and then we have to just figure out what 14 times 64 is.
Okay. And then what are we going to do once we figure out what 14 times 64 is?
Take 14 over that.
Okay.
So we're at 1/64th, and then.
So hold on one second. So the fact that there are 14 rooks on every square, and we add them all up, that means we have 14 times 64 rooks, right?
And then
we
divide that by 14.
right. So we have 14 divided by 14 times 64, and so what's that?
64? No, 14 divided by...
14 divided by the quantity, 14 times 64.
That's 1 over 64.
That's right. So how long is it going to take a rook on average to return to where it started?
So it's about 64 moves on average.
About 64 moves on average. Now, that was kind of complicated, but can you tell me why that might make sense? Why would it take 64 moves on average for a rook to return to where it started?
Well, there's 64 squares in a chessboard.
Okay.
Well, it makes sense because the rook, no matter, it doesn't have to do anything special to get back from where it is. Wherever it is on the board, it can go some down or up, and some left or right, and it'll get back to where it started.
Okay.
So anywhere it can take 2 moves to get.
Yeah, it can go anywhere in 2 moves.
Yeah.
Can you understand why? Do you understand why 64 moves for the rook makes sense?
I guess, yeah, because it can like easily, you can like see how it can just simply go like you said, anywhere with 2 moves. And, well, 64 is also the number of squares on the chessboard.
Oh, wait a minute. Yeah, 64 is also the number of squares on the chessboard. So what does that mean, that it's going to take 64 moves on average to get back to where you started?
Every square on the chessboard.
Yeah, you think, well, maybe it'll hit every square. And see, the thing we had with the rook distribution is all the squares were basically the same.
Yeah.
So there's no real preferred motion for the rook.
Yeah, so it just goes anywhere it wants to.
Yeah.
Whereas with a knight, the squares were not all the same because of the weird way the knight moves.
Yeah.
But now we're going to try to figure out an extra challenge. We're going to do it with a bishop. Okay?
Alright.